Hi, I'm Professor Goines. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in mathematics ranging from algebra on up from there, please consider subscribing to our channel, watching our videos, checking out our playlists, sharing, liking, commenting. All those things are greatly appreciated. So let's go ahead and get into the current one. What I want to do is take a look at finding the domain and range of a function from its graph. Now, first and foremost, let me remind you, if I have a function value just generically written here as f of a equals b, input A, output B. A's in the domain, B's in the range. Like all those pieces of terminology we'll review here in a moment. But again, if I have this function value, how is that related to the graph? Well, the graph consists of, if I have this function value, f of a equals b, then I know that I have the point a comma b is on the graph. A comma b would be, say, this ordered pair right here, where a would be the x value and b would be the y value. Now, what I can do from this is I say, well, remember the domain is the x value, so that's going horizontally. So in particular, if I had started with this graph, I could see that the value of a is in the domain, because if I go to the x-axis to a, there is a point on the graph that uses that a value. And then I see that the value of b is in the range, because if I go to this value of b on the y-axis, there is a point on the graph that uses that as a y value. Okay. Now what I want to do is, rather than highlighting specific points, although that is going to be part of the discussion, is how do I use a graph to find the entire range and the entire domain? Okay. Now, just disclaimer, finding a domain range from a graph is very inaccurate. It is used only in very special cases. It's used sort of as a building block to finding domains and ranges from a function expression, which is the more appropriate way to do it. Nevertheless, we will take a look at this concept in detail. As a reminder, what is the domain of a function? Let me write this two different ways. First and foremost, informally, it's all x values. And this is generally the way that we will think of it, is it's just all the x values. If I'm going left to right, x values, the horizontal axis is the x-axis, so domain is everything in this direction here where there is a point on the graph. More formally, it is the set of all x such that f of x is a real number. In other words, it's all the numbers that I could plug into this function so that the output is a real number. Like I'm not dividing by 0, I don't have negatives under radicals, things like that. If I can plug a number in and the output is, say, 7 or 2/3 or pi squared, then that would be an element of the domain. On the other hand, what's the range? Well, the range, informally, and the way that we generally think about it, talk about it, is all y values. Y is the vertical axis, so how far does the graph go down? How far does the graph go up? Wherever we are on the y-axis where I can find a point on the graph, that would be an element of the range. But what's this a little bit more formally? It's the set of all y such that y is equal to f of x, where x is an element of the domain. Okay. Keep in mind, we're really not going to use the formal definition, but the formal definition is, well, if this is the domain, then if I take an x value and plug it into the function, what are the y values that I get out of it? Okay. I plug in every single x value, and then it's just a mass collection of all those y's is what my range is. Okay. So now we have an informal and a formal version of the concept of domain and range. Now let's take a look at some specific examples and find the corresponding domain and range of those functions. For example, let's say I have the following graph. And we'll go ahead and put some marks here on the x and the y axis. Let's say this goes to negative 5. This goes over to 6. So on my x-axis, say on my y-axis, let's say this goes down to negative 4, and this goes up to positive 5. Now, if you see an example, say in your textbook or in your homework, chances are you're going to be given some sort of a grid here. And I don't want to, kind of blow this up by putting just a whole bunch of vertical and horizontal lines here to, to make a picture that looks like this. Right, and say here's the x and here's the y-axis. Again, it's not very accurate for me to do on the whiteboard, so I'm just going to label the far endpoints of the x values and the y values on here. Now, what you would see on your homework is you'd have vertical lines here, and you would count back, and you would say, well, how far does this go to the left? And you'd count back how many lines, and then put you in, say, negative 5. So again, I'm just going to abbreviate it by putting the endpoints of the x and the y values on the graph. Okay, so let me get this awesome little picture out of here. So I'll get that out of my way. All right, talk about the domain. Again, domain is all the x values. What we do is we say how far does the graph go to the left, and then we start working our way to the right. See how far it goes to the right. Well, the farthest that this graph goes, just visually speaking, would be this point right here that I've got colored in, and then what I'm going to do is I'm going to list the corresponding x value. Now, this ordered pair here, if I was to list the coordinates, this would be back 5, down 4. Okay. Now remember, domain is the x values. So that means that the absolute smallest, or at least the number that's farthest to the left, x value would be negative 5. So go ahead and I'll list that, negative 5, comma. Now notice that if I start at negative 5, I'm using all of the x values. In particular, say I'm using this one right here because there's a point on the graph. I'm using this one right here because there's a point on the graph. Well, I'm using all the x values until I get up to 6. After the comma, then, I will put the number 6. The other thing I have to take into consideration, are these numbers included or not? I know everything in between negative 5 and 6 is included. Certainly 0 is, and certainly, say, 1 and 2 and 5.2791. But what about the numbers negative 5 and the number 6? Well, this is where we use the notational convention that if I have this dot scribbled in, that means that that point is included in the graph. So it is actually a point on the graph. And if a point is included, we use a square bracket. Okay. Now over here, if I look at the number 6, directly above that I have a circle that's not scribbled in, and the convention is if it's not scribbled in, that means that it's not included, and not included means a parenthesis. Okay. As a quick reminder, this notation means x is, oops, I already made a mistake, didn't I? X is less than 6 and greater than or equal to negative 5. So this square bracket corresponds to a greater than or equal to sign, and 6 with a parenthesis means it's strictly less than 6. All right, let's go ahead and list the range. As I mentioned over on the far side of my screen, the range is all the y values. So how far down versus how far up. Okay. Formal definition, sometimes we'll kind of use that to highlight things, but generally speaking, when we go through examples like this, we're going to use the informal definition. Okay. Range, well, how far down does the graph go? Well, if I'm looking visually, I can highlight that it's this point right here. Again, the same point as with the domain, which is the farthest to the left. It just so happens that this point is the farthest down I go. Okay. And range is the y values. Therefore, we list the y value of that point, which of course is negative 4. All right. with the very smallest, or at least the y value that's at the very, very bottom is -4. I'm using all these y values. Okay, so I'm going to use a word that I haven't defined in probably in this current course yet, whatever your algebra class you're taking. Continuous. Okay, so this is then continuous, right? There's no gaps, there's no holes, there's no jumps, nothing like that. I drew it without lifting my marker in this case. I'm using all of the y values, right? I'm using this y value here, or this y value here because here's a point on the graph. I'm using this y value here because here's a point on the graph. This y value here because here's a point on, this y value because here's a point on the graph. All the way up to, well, the very top of this would be at the ordered pair, over 6 up 5. Okay, so 6, 5 would be this point right here, and the y value is 5. Therefore, I will list the y value of 5. Just like we did with the domain, we also have to include information in my my interval notation regarding if I'm including that point or not. Same story. If this is closed in, that means included. -4 is the y value there, so that is included. 6, 5, well, 5 is the y value. This point is not included, so I'm not using the 6 or the 5. Actually is not part of the graph, but 5 would be sort of like the very top, and so therefore that would be not included. Okay, so therefore my range would be from -4 to 5. Okay. Let's take a look at another example. Still getting used to using the light board, and sometimes if I erase kind of hard, it kind of shakes. I'm trying to just hold it so it doesn't get all flopping around here. Let me go ahead and erase this, and we'll take a look at another example of finding the domain and range from the graph of a function. Again, this is usually just a building block to kind of start the discussion of what a domain and range is, and it kind of gives you a good visual for what it represents. But in practice, it is not very accurate, unless we have very specific graphs like this one right here. If I give an arbitrary function, we might not even know what the graph looks like. So again, it's just sort of a building block. At any rate, let's take a look at another example. And let's say I've got a graph that looks like the following. Quick reminder, of course, this is the x-axis and this is the y-axis. So the x-axis is applicable for the domain and the y-axis is applicable for the range. Okay. And just to make sure this is, you can read that, this point here is an open circle, so not included. This one is an open circle, not included. This one is a closed circle, so I scribbled that one in. Okay. Let's find the domain and the range of this graph, or of the function represented by this graph. So domain. Right. Well, again, what I have to do is something like I did over here. I have to give you some sort of a scale. And so let me give you, let's say if I was to go over here, let's say this is -6. Let's say over here is, let's say, 10. Let's say this is -3, and let's say that is +5. Okay. Again, on your homework, you might not be given those exact values. Like, okay, so this closed dot right here is at 10, but what it might do is it might give you, say, like graph paper, where you have to just kind of count over how many tick marks, and it's, you just count over to 10. Okay. So I'm just going to, rather than putting all those tick marks in here and put all those grid lines, I'm just going to tell you the span of how far the x values go and the y values go. All right. Now, let's see. How far does the graph go to the left? Well, the farthest that the graph goes to the left would be this open circle right here. And again, domain, so x values, how far to the left? go to the x-axis, and I'm going to record this value. That means I'm going to record -6, comma, okay? That means it's -6, or at least everything bigger than -6 until I get to where? Well, again, this is continuous. I'm using all of these x values, right? For example, I'm using this x value right here because here's a point on the graph. I'm using this x value right here because here's a point on the graph. I'm using this x value because here's a point on the graph. How far does that go over? Well, it goes over, I'm using all the x values until I get to the one that represents this open circle. And I didn't give you a point for that, so let's just keep kind of ballparking my scale here. That looks like it's about probably 3. Okay? So I'm using all the x values between -6 and 3. All right? There is more, but once I get to a point to where I'm not using an x value, I do have to put sort of a stopping point, so a comma and then that number. All right? There will be more information over here, but let's go ahead and wrap this one up. I'm not including the -6, and I'm not including the 3. All right? Now, where did the x value start again? Well, it looks like everything bigger than 3. So 3 is not included, so I'm going to put a parenthesis with a 3. Okay? And then how far does it go over? Well, it goes over to this point, which has an x value of 10, and that one is included. Okay, now piece of notation. You know, if this was, say, like an English class or whatever, and we were like, listing, listing things, we usually put like, red, comma, blue, comma, green, and white, right? We put commas in between. So you might think, okay, well, what's this or this? Let's go ahead and put a comma there, right? But in mathematics, we don't use that comma. Again, it could sort of get, confused maybe with one of these commas. So we use a different symbol, and I'm going to use what's called the union symbol. Okay, so the union symbol is going to be a capital U, and it stands for OR. Right? Now, let's look at the range of this function. Okay. Range, y values, how far down versus how far up. Well, how far down does the graph go? Well, visually speaking, it would be this point right here, and the y value is -3. I'll go ahead and I'll list -3, comma. All right. Now, as I go up the graph, I am using all of the y values that are above this, or at least initially above it. For example, -2, because you have a point on the graph here. I'm using 0 because here's a point on the graph here. Now, not only is there a point on the graph here, but there's also a point on the graph over here. So some of these y values are actually used twice. In particular, the y equal to 1, which would be ballpark about right here, is used not only at this point, but also at this point as well. Okay. Now, for the range, it doesn't matter if I'm using a y value more than once. We list it once. All right. -3 up to where? Well, I'm using all the y values until I get to the top of this, which will have a y value of 5, and therefore it would be -3, comma, 5, and neither of those are included. Therefore, this would be your range of the function. Okay. So just to recap, domain, how far to the left, how far to the right, x values, range, how far down, how far up, that's the y values. Thank you for watching, and please consider subscribing.